thank you so much, everyone, for joining this evening. And I would like to request Dr. Jyotirmay Mathur to introduce the background about Professor N.K. Bansal Memorial Lecture. Dr. Jyotirmay Mathur.
Thank you, Kushagra, and a very good evening to all of you. I'm really delighted to be part of the third Professor N.K. Bansal Memorial Lecture Series. As we all know, that Professor Bansal was a pioneer in the field of renewable energy as well as energy efficiency in buildings in India. He served at IIT Delhi for about 30 years, and he has directly and indirectly influenced careers and lives of more than 100 professionals in the country. He supervised about 40 PhD candidates, more than 40 PhD candidates, and I think about 200 or more tech students while he was teaching at IIT Delhi. He was sort of a founder of Sri Mata Vaishno Devi University at Jammu, created the campus and the entire infrastructure, and kind of brought the university from nowhere, its name in part of the country. And then later, he was part of the CEPT University on Syntax chair. Professor Bansal was, to be very frank, he was much ahead of the time. He always talked about a research area which was to come to hit India 10 years down the line. So he was much ahead of his peers, and that is what kept him at the forefront of technology, research, industry interaction, and so in his memory, we started this lecture series. The first one was delivered by Dr. Ajay Mathur, who has been the Director General of Bureau of Energy Efficiency. And today's presenter, Dr. Dru Crawley, he has worked closely with Professor Bansal as well as Dr. Ajay Mathur. Even coincidentally, the second speaker has also been a good friend of Dru, Mr. Padhu Padmanabhan, which several initiatives related to energy efficiency in buildings they started in India. So as a third chapter of this prestigious series, we have Dr. Dru Crawley. I would request Kushagra to please introduce the speaker. He has been a great friend of India and energy efficiency initiatives in India for past 20 years or so. I would hand over to Kushagra for introducing the speaker. Thank you.
Thank you, sir, for the background, and thank you all the participants for joining. It's a pleasure today to introduce our speaker for the day, Dr. Dru Crawley. Dr. Crawley is the president of IBPSA since 2022, and he has been an at-large board member of IBPSA since 1998, and past IBPSA vice president and secretary as well. Not only IBPSA, but he's been very active in ASHRAE as well, and he's a director at large at ASHRAE, an ASHRAE fellow, and ASHRAE DL. He chairs Standard 169 Climatic Data Project Committee and is a member of SSPC 189.1 and several TCs. He has more than 40 years of experience in energy efficiency, renewable energy, and sustainability, and he has worked in engineering software, government research, standard development organizations, as well as building design and energy consulting companies. He is a Bentley Fellow and Director of Building Performance Research, thought leader focusing on building performance, zero energy buildings, decarbonization, digital twin, climate change, smart cities, resilience, and sustainability. On behalf of the board of IBPSA-India, the president, SMH Adil, past president, Dr. Jyotirmay Mathur, and the entire board, I welcome Dr. Dru Crawley to this third N.K. Bansal Memorial Lecture. And now I'd like to invite him to initiate the lecture. Dr. Crawley, please.
Thank you very much. Today, I'm delighted to give you a talk about going digital, and particularly looking at decarbonization and resilience, but also just the ability to model up to city scale, to use that in various ways to make our buildings and our cities better. I always like to sorry. I always like to start my talks by talking about energy. That's been the focus of most of my career. But if you look at the world, the first bar, the building energy use is about 30% of global energy use. It varies quite a bit. If you look at the third and fourth bars, it's China and Hong Kong. China buildings today account for about 20% of energy, but that's up from 10% 25 years ago. And that's primarily due to the huge growth in buildings there and concentration in urban areas. At the other extreme is Hong Kong, where buildings are 65% of their energy use, of Hong Kong's energy use, with a substantial amount for transportation and very little industry. And if you go the next bar, you see that India is already in the range of about 25% for buildings and growing as well. But industry still accounts for 60%. And you see it varies quite a bit depending on what the focus of the economy is and whether that's industry or finance and buildings specifically, such as Hong Kong. The US, we have about 40% today, and that's also been growing as a percentage. Starting talk today to talk about how we're already able to gather information, very detailed information, even getting that from photographs. This is a model that was created of Paris. The overhead was done by flying a plane through the city and over the city, and then it can be merged with ground information where multiple pieces of data or is being collected. It's a very detailed model. You can get very fine resolution with this, and you'll see as we go through some of the examples today that you're able to collect more than just the mesh model, which is what this is, and being able to merge that. 3D modeling is now possible to do through a federation of data. It no longer has to be a single way of getting that. It can be a cell phone, it can be LiDAR, it can be drone, any of a number of different ways that you're trying to collect information. And all that can be done in a single model to bring that together. So here's an example. One of my colleagues in Canada is taking multiple pictures of an object that's just being a mock-up of piping just to get some feel. They're sent to the server comes back, and then you have a mesh model with photos applied to be able to look at it. It's detailed enough that you could probably measure, you can read information off of the any words that may be on the printed part. So one of the early attempts to really look at modeling the city, but also looking at the environmental impact has been was Philadelphia. And that's primarily because my company's headquarters is near Philadelphia, and we've done some work with the city. This was particularly when the Pope went to visit Philadelphia, and they were looking for security and how that could be meshed. So they had a model of the city, as you can see here, but within a BIM environment, we're able to add the security fencing and other things so that they were able to understand line of sight in other areas. But this was, for me, it became a very interesting model because we had a 3D model of a city, but we also had data. In the US, there are about 30 cities now, 30 of the larger cities that have implemented a program of benchmarking. And what this is, they require private companies or private owners of buildings to every year submit their utility bills, their electricity, natural gas, and even water, and be able to have that in a public database. Well, it happens that Philadelphia is one of those cities that's been very aggressive about getting that information into the public. They have it. They have a open public database. It looks at all sorts of information. And I would say this is large commercial buildings, so we're talking anything over about 5,000 square meters. It doesn't capture most of the small buildings, but they know where it is the building area, what type of business is there, and other data related to the building. In addition, they have energy at site. They have primary or source energy. They have it by fuel type, but they also have water use and Energy Star score here in the US. But the data looks like this. It's kind of a spreadsheet sort of approach to looking at the data. You can sort on all the various elements there, you can look for a specific address, but it's not very functional in the current form. You can graph it. They have a map possibility. But what we did was start to overlay the data that's in that database over the 3D mesh model that we had and begin to look at it. So with some color coding, blues and greens are lower in intensity and red is higher, and just to begin to take a look at that. But it's not just a static model that we can take a look at. We can now begin to go within the tools and look at individual buildings and see what's going on for property. So if I identify a property that is high energy or red showing on here, I can begin to work with that and try to find more information. Whoops, I'm sorry, I didn't let it run a little bit. But there's additional information about energy for that building, and it's all organized within a tool that you can use to go in and grab additional information and start to make some judgments about individual buildings. The idea of a digital twin has been around for a while, but as a concept, it's been catching on more lately, and we'll talk a little bit more about that. This is Microsoft's new South Pacific headquarters. It's there in Singapore, and they occupy the 9th through the 14th floors of this particular building. Now, this is a kind of a different sort of model. This is where the digital twin or the 3D model of that particular building has been brought in from BIM drawings. And that's one of the nice things about the digital twin, is to be able to look at it, not just a mesh model, but you can bring in that as well. What they're showing as they're going through here is different sensors that have been linked to the model to be able to show how quickly or what's going on. And for example, they're showing occupancy sensors for that. If we look at transportation, key area for many locations, more transportation infrastructure needed, and that makes it a digital twin a very handy tool for being able to look at that. Here's an example of a roadway that's going through a city, and they're looking to add a new ramp for that city. And the nice thing about once you have a digital twin, you can look at it in 3D, but you can also animate it to show how that new infrastructure might look in operation. Another one, this is using it for modeling an existing roadway, but also to look at how that can be managed, particularly to make the road smoother, to take out bumps in what's going on there. So the the user is going in and looking at the data. This is done with a point cloud in this case, and the roadway is then the information is fed to the machines, which make it can directly use that information. As far as water and stormwater, also very critical, particularly as we've been having increasing climate emergencies and flooding and storms that are beginning to really affect many of our cities globally. This is a colleague of mine in Canada again, and what they have done is added the information about the utilities on top through a virtual reality set of goggles to be able to look and see where the utilities are underground, so that they have modeled that entirely. So without having to dig, they know where the water utility is in this point, the water piping that's going through the city. Similarly, this is Paris again, a different model, a bit newer model than the previous one I showed you, but this one is ability because the information in the model also has elevation and what level the river is, etc. They're able to simulate flooding and where that water is going to go into particular areas. They also can use it to see what level of maybe the embankment they can bring up a bit more to prevent flooding in particular areas. And that is one of the models that I think we've been seeing a lot more in use to be able to for infrastructure planning, particularly flood prevention. There's also another tool which has become very interesting, which is agent-based simulation. And agent-based simulation can be used to model how people move through spaces. In this particular case, this is a new subway station. They did the simulation with the anticipated load, but this is done within the BIM model and being able to bring that in. So they've gone from 2 to 4 turnstiles to look at what the impact, and it reduces the congestion that we saw earlier for that. So that's another powerful tool for within the digital twin realm. Also used for looking at egress. This is at a football stadium, looking at, for safety purposes, how are people able to get out of the building quickly? Also using 4D GIS data, able to look at and simulate what a new developments in an area Singapore was going to do to traffic, how that was going to affect it. And that, so they're able to look at particular elements of that. One of the interesting things, one of our early partners has been the city of Helsinki, and they've actually done 3 generations of a model of the city, and they used a drone again to measure that. This is not the 3rd generation model. The 3rd generation model has a resolution of about 10 centimeters. So you can actually look at individual buildings and measure how big the building is and where the windows are on the buildings, etc. So a lot of information there. They again used it as a flood model because Helsinki is surrounded on multiple sides by water. And so they're able to look at that and a little playful there with the boat going through the main square. But to see where the problem areas will be and to look at that, because the city is not entirely subject to flooding, but they do need to do some work to be able to resolve that future possibility. This is the 3rd generation model. This is their new reality mesh. They covered the historic center, about 26 square kilometers. What they're using is some deep learning, machine learning techniques here to identify what are the various elements of the of that model so that they can determine what's vegetation, roadway, and what are buildings. And that's kind of an important piece there. One of the interesting things that Helsinki has done is take a look at how that 3D city model, their digital twin, can be used. And they started looking at carbon neutral, smart city services, web services, business, marketing, tourism, city planning, traffic. You see a long list there on the left side. And across the top, what are the data sources that need to be used? And so that city information model, along with the reality mesh we just saw through planning, design, analysis, simulation, virtual and augmented reality, sensor data, big data, lots of different ways of collecting and using data in a single model. Now you see that they've made some progress there with the where the green dots are. And blue means they're beginning, but see all the different aspects that they've really not even touched, be able to look at that. But I think that's, they continue to use that as a process for going forward. One of the interesting projects recently that Bentley has been able to work with is a project between SEPT University in Ahmedabad and University College London. And the idea was to create a model of Ahmedabad, not just a mesh model, which is what you see, an early mesh model here for that, but to dig into it with more data. And so we do have in this a mesh model based on flying the city, trying to capture 250 square kilometers of the city. It's a very ambitious project. I haven't seen one quite that ambitious. And being able to look at the data and collect some of that, not only the data from the 3D drone flown model, but also to collect other data. And so here's the point cloud output, just beginning to look at that. Then looking at using some of the machine learning, deep learning techniques to be able to look at identifying specifically what the footprint is, what are trees, and then you can get specifically the actual footprint from that. Very, very powerful tool. From this, they were able to create energy models of each building. They had information about size, etc., and beginning to look a little further so that because the model is 3D, they could then also identify windows and doors and other openings to be able to calibrate that model more closely to the utility bills that were available. The other interesting use of that is to be able to look at some of the buildings, again, like we did in Philadelphia, to look at energy use intensity and see where the opportunities for maybe retrofitting buildings or attacking the energy problem and understanding them better to see what the various types were. And they can be grouped. The small chart there on the middle right shows the type of building, whether it's commercial or residential or education, hotel, hospital, or retail. And so you can begin to identify where the areas are. The bulk of the buildings in Ahmedabad, of course, are residential and range in energy use intensity quite a bit. Can, again, like the Philadelphia project, but with substantially more data, zoom in on a single building. This is a residential building. Let's see, what do we got? 200,000 square meters, 14 floors. They did not have a measured energy performance index, not code compliant, but they did do a simulated energy performance index and came in at 75 kilowatt hours per square meter, compared to the other buildings in the neighborhood or other typical buildings. It actually was much better. but still they were from that being able to look at cooling, the internal equipment, lighting, and other end uses to see where retrofit opportunities might be appropriate for that. The last twin I'm going to show, Singapore as a city-state has created a digital twin of the entire city, and it is an interactive digital twin. This is just a part of the mesh model, just to show you kind of some of the iconic parts of the city. But their intent is to keep it growing. As new buildings come in, they get added to the model, and to move that. So transportation comes into that, energy, water, and other information that they can collect and provide. So definitely a planning tool and a tool for moving forward. So what does that mean with the future? Well, instead of disconnected information, now we can actually have information coming together so that individual buildings can talk to the energy system, the renewable system, being able to look at various elements there. The building in its context can know about climate, security, energy use. The model can be used for planning. Also, though, for roadway traffic management, parking, being able to look at safety again and autonomous vehicles, which are making their way slowly toward us. That tied in, of course, with the water system and the stormwater and even other systems like rail. So the idea is taking it to a connected infrastructure digital twin and really being able to move that in a positive way. So no longer will buildings be isolated. Their information can be shared, but also it can be used to minimize energy use and take advantage of renewables and other possibilities for them. So in summary, 3D digital models, the digital twin, make it easier to understand our buildings, their context in the community, and how they interact with the environment, and at the city level to begin to look at that. Once we have models such as that done initially for Helsinki, but also Ahmedabad and other locations, that sort of detail allows planners and city officials to begin to understand how the built environment is really impacting energy, and they can begin to make move forward on that. It is a federation of data. It's not a single aspect. It can be lots of different ways of getting the reality information. That mesh or photos or point cloud all combined together. The data and analytics is other layers on that, make it an incredible resource to be able to know more about what's going on in individual buildings, but also at the city scale. Platforms are not tied to a single vendor, and the data can reside anywhere, probably most likely cloud today, but that information is can be controlled and maintained by the owners of the data. This will give us a way to really look at risks, resilience, and sustainability issues in a holistic way, to be able to understand not just the individual building, but understand the context and how that interacts with other buildings and with the city itself. And it allows many different disciplines to be able to pull that together, which is very powerful as well, allowing people to be able to understand that context and be able to work in the same model, whether they're architects, engineers of various disciplines, or at city planning level, or even regional and government level. And this should say with 5G deploying now, data connectedness is really going to make this possible, making it a powerful tool so that real-time data can be shared. And beginning to see that high-speed 5G being deployed in my own city in Washington, D.C., seeing speeds on my mobile that rival what I can get with a wired connection in my home. And so that same sort of idea of being able to provide that data real time and quickly to be able to have timely information is going to be important. That's probably going to be first deployed for doing traffic management, being able to manage flows and in that area. We're seeing that also public safety, where cameras are being deployed to be able to capture crimes as they occur and be able to help the police solve them quicker. And essentially what it means is that anything that is now measured locally, and you think of your building as kind of a standalone island, now it's going to be part of an interconnected grid of a twin of the city itself. So smart buildings through IoT lead to smart cities, and that's going to be a really important part of moving forward over the next few years. So if you're into building simulation and looking for data for building simulation, Climate.one building is a free data source. I believe there are 80 locations in India these days. It's a data source of over 16,000 locations globally at this point. And with that, I'm happy to answer any questions.
Hi, Drew. This is Vishal here.
Hi, Vishal. How are you?
Yeah, I'm fine. Thank you. And a fantastic presentation. Thanks a lot. Uh, I have a question, or rather, two questions. Uh, Drew, one is how expensive it is. Like if more cities or more areas would like to create such digital twins, what are the resources required and how expensive it is? And number two, how much are these digital twin being used for real-time data and analytics and decision making?
I don't have an exact cost for that. It depends on level of complexity and the type of equipment you're using to be able to do that. Uh, the Paris models were created using a small airplane, which of course had permission to fly the city, and they had tens of thousands of pictures to do that. Omnibod was done with a drone, and as was Helsinki. So the cost of that is really more in time to prepare that. This can be done locally on clusters of PCs, but some of the cases, the more complex cases, can be run on that. So I guess the answer is it depends on how complex the project you want to do and how expensive it's going to be. I think it's the cost of the people more than the cost of the machines or the in the time involved, rather than the software or other aspects of it. There are a wide range of providers on that, so some of them are available quite inexpensively. I have not seen this used to collect real-time data at the scale that we're talking about here. I have seen it like the Singapore, where they are looking at elements of that for real-time for traffic control, because understanding that there's a traffic jam in one area means they can open up, speed up traffic lights in other areas to try to resolve the congestion. And being able to do that real time either just at the stoplights or feeding information to apps on our phone that say, well, the traffic ahead is getting congested. Here's a different route we should use. So that sort of thing is happening now. It's not in the context of a true city twin at this point, but we are beginning to see opportunities like that. One of our partners, University of Texas, is in the process of attaching all the real-time signals to digital twin that they're producing for their campus in Texas. And so we're beginning to see that sort of look at it, but not at the scale of an entire city yet.
Okay, thank you.
Are there any other questions? Feel free to unmute or maybe put them in the chat box.
Good evening, Dr. Dru. I am Saptarshi. So firstly, thank you for the informative session. So my question is more specifically related to building integrated photovoltaics. So if we consider a city level potential estimation, like especially for the Indian scenario, there is very limited data on the number of mid-rise or high-rise buildings in a city, which are very good sites for BIPV installations, especially if you consider BIPVs installed on the facade of the buildings. So can you suggest any good methodology or tool to do this kind of an analysis?
I think this tool is very powerful for doing that. Let me back up for the one of the Omnibot pictures showed that particularly. Here's one of the buildings in Omnibot, and now being able to look at what are you could identify areas and go in and actually measure where BIPV could be added to that, either on the roof, maybe some of the building facade areas as well. And so that's one of, I think, the powerful tools. We may not have, may have drawings from many years ago, or maybe not, they could be lost, but being able to pull that information and go in and measure to look at a particular building is very powerful.
Okay, thank you.
Thank you. Any other questions?
Dru Jyotirmaya.
Good evening.
Good evening. So in building level simulation, the way we have calibrated simulation and we have opportunities to tweak our model and refine our model. Is there something similar when we are operating at the city level simulation?
Not at an integrated look. We're still looking at individual buildings. I know there have been a number of projects, particularly at universities, looking at urban scale modeling. So you're modeling not only individual buildings, but the areas around them to be able to look at temperatures and vegetation coverage, etc., but not truly an integrated whole city level. What you're seeing are mostly still models of individual buildings that are kind of placed within the digital twin.
So actually the reason why I was asking this is if we want to model urban heat island effect or any other effect, for example, flicker or glare by photovoltaics on one building to another building.
Yes, yes. I have seen that that sort of modeling happening. I don't see it at in the individual building energy models, but do see it more as a kind of a looking at the context of the building and how you might get reflections off buildings because of their glass or other areas, but not directly within the context of an interactive building model.
Hi, this is Pooja. I'm just wondering, do you have a centralized team of data analysts who's analyzing this data and just putting it in this model and gleaning information from it?
Not a centralized pool, because it kind of depends on what they're looking for. The a lot of the things that we're looking at are really a good application of big data, also artificial intelligence, some of the elements they are looking so that let the machine try to get some insights for that. And that's one of the reasons that they were using the deep learning, machine learning aspects of some of the tools to be able to look at data because it'd be very difficult for a person to go in and individually identify the footprints of buildings, for example. And so that's where I think the biggest opportunity for AI is in these tasks that, yes, they could be done by a human, but that can be done much faster by machine and analytics.
Okay, that makes sense. Thank you.
Great. I have a question for you, Drew. I mean, in the world has like evolved in digital twin, and a lot of modeling is now feasible, and a lot of data collection is also now feasible through cameras and various devices, like you mentioned. And I'm aware of a lot of software like Matterport and other BIM tools. In all these advancements, where do you see the future of building energy modeling and standalone tools like eQuest and IES and those tools which were not integrated with the whole building model, but standalone energy modeling tools?
Well, I think they're a very powerful adjunct to something that it scaled the city model, because you can go and look at individual buildings with those tools. But doing so within the platform, maybe that's not quite there for a lot of those tools are kind of intended to be more standalone user interfaces wrapped around an engine. And it takes a platform like a building information model or BIM to really be able to have an integration of that, because it does BIM primarily. I think I see it used more as a 3D drafting tool for design, but the reality is it has the power because it's not just geometric information. It can have thermal physical properties, it can have other information, scheduling information. All of that can be embodied with it. And if that's tied into an energy model, then that's where it becomes really powerful. Being able to automatically generate those models it is very much part of what we're trying to use all the data flows rather than just looking at individual buildings that we had to start from scratch.
Thank you. Any other questions from anyone? So, hearing none. Yeah.
Dr. Crawley, I have a question if you're familiar with heat mapping that they're doing in certain cities and how that might be used to, integrate with, what you're doing.
Heat mapping is applied to what?
So basically they heat map cities to see where the pockets of heat and energy are on the roads and the streets. And they try to build, plant more trees in those areas, and that, indirectly would help the, the buildings as well. So are you familiar with?
I am, and many of the city urban modeling that I've seen is dealing with that in context so that you have more information. It definitely needs to be considered, partly because I showed that there were 80 or so locations in India with weather data, but that doesn't help me look at what's happening in the urban context. in the US, they've been doing studies looking at what the heat island is actually looking like in various cities. In my own city in Washington, D.C., they took measurements throughout the city on a very hot August day, hot for us. And temperatures were in the mid upper 30s. And it was kind of eye-opening to see. We actually have large areas of parkland within Washington, D.C. There's a national park that extends almost from the White House to the northern border. So it's on the order of 3-4 kilometers in length. And when they did the measurements for that, the center of the city, where not so much the ceremonial part, but the business side, they were seeing temperatures that were 10 degrees warmer, 10 degrees Celsius warmer than what they were seeing in parks. And so really having that information, it can be critical, because if we're looking at just a snapshot of the locations in where the climate data may be available, that it can show the significant difference in energy. So I think heat mapping can guide us to understand where we are going to have problems. And so, yes, definitely a good tool.
Thank you.
Perfect. Any other questions? Great. I think that's all the questions. And now, to invite for the vote of thanks, I would invite my fellow colleague from the IBPSA-India board, Dr. Yash Shukla, who would present the vote of thanks.
Thank you, Kushagra. Thank you, Dru, for a wonderful session. We always enjoy listening to you and hearing about what's coming in the future. As you can see, that your talk really led to a lot of questions and a lot of curiosity questions as well. So I know it's an early morning time for you. So thank you for taking the time for this lecture. This particular lecture, as I think Professor Mathur explained, Professor N.K. Bansal Memorial Lecture is very special for us. And so with your connection with the IBPSA simulation and ASHRAE, we thought it's really an honor to have you here. So thank you again for taking the time for the lecture. Thank you for all the participants. We had a good number of participants in this webinar. So it was wonderful to have good participation and interactive session. To you,
Thank you, Giannis.
With this, we close the third Professor N.K. Bansal Memorial Lecture 2023. We promise that the fourth Bansal Memorial Lecture will be organized next year, which will be of the same quality as we had the first three lectures. Thank you. Thank you very much. Good evening.
Thank you, everyone. Thanks for joining.